Hello everyone, welcome to day 2 of polar coordinates. Today we are actually going to be working with polar equations. So instead of just working with points in the polar coordinate system, we're going to be working with equations in the polar coordinate system. So an example of a polar equation is something like this. R is equal to 4 cosine of theta. So if you oopsies, didn't have that quite pulled up. If you go here, this is what the graph looks like in the polar coordinate system. So r is equal to 4 cosine theta is obviously a circle, as you can see, and that's what it looks like in that polar coordinate system. So every point on this graph satisfies the equation that its radius is equal to 4 times the cosine value of that theta that we're at. So you might notice that I have another equation set up for that, but we'll get there, don't worry. So we want to convert this into rectangular form. So a few key notes to remember is that r squared is equal to x squared plus y squared, and then that x is equal to r times the cosine of theta, and y is equal to r times the sine of theta. So that's going to help us out quite a bit here. So if you notice though, we don't really have anything that we exactly want. We have r, but not r squared, and we have cosine of theta, but not r times cosine of theta. So it's really going to help us out a lot if we multiply both sides by r. So once we do that, we now have r squared is equal to 4r cosine theta. Bingo, this helps us out huge. R squared, we know, is equal to x squared plus y squared, and then r cosine theta is equal to x. So we have x squared plus y squared is equal to 4x. So we could leave it like that, but that's not really in a form that is super useful for us. Like, I don't know, I look at that and I don't know what graph we're looking at. So we have an x squared and a y squared, and usually when we have an x squared and a y squared, it's some kind of circle. And you'll notice that if you remember back to the graph that I just showed you, it was a circle. So let's try to get it into that form. So we're going to subtract the 4x from both sides, and we have x squared minus 4x, I'm going to leave a little space, plus y squared is equal to 0. And this would be super handy if we could get this x squared minus 4x into some kind of parenthetical form that's squared. That would be pretty nice. How can we do that? Little blast from the past, we're going to complete the square. So when we complete the square, we take our b term, which here is -4, so a little sidebar here. We take b over 2, and we square it. So this gives us -4 over 2 squared, which gives us -2 squared, positive 4. We add that to both sides to keep everything legal. And then you'll notice we can rewrite this as x minus 2 squared. So if we were to FOIL out x minus 2 times x minus 2, we would have x squared minus 2x minus 2x, boom, minus 4x. And then -2 times -2, boom, plus 4. And then plus y squared, and that's all equal to 4. So this is the equation of a circle with center 2, 0, and radius square root of 4, which is equal to 2. So if you go back with me to our graph on Desmos, we get rid of this, we enter this here, and then I'm just going to switch the grid so that we're Cartesian. Boom, we have a center of this circle at 2, 0, and a radius of 2. So those equations represent the same graph. So I want you guys to pause the video and give these two a try, and then once you're done, hit play and we'll go through them. So this first one here you'll notice again that we have r by itself, and then we have cosine theta and sine theta. It'd be really handy if we could either get this as an r squared, or if we could get this to have an r in front of it. So what I'm going to do is I'm going to multiply both sides by 1 over r. So when we multiply both sides by 1 over r, these cancel, and we have 1 is equal to 2 over, and then this r distributes to both terms, so we have r cosine theta plus r sine theta, which is super handy, right? Because this is equal to x, and this is equal to y. So now we have 1 is equal to 2 divided by x plus y. Again, not super helpful, but if we multiply both sides by x plus y, we get that out of the denominator. I'm just going to move up here. So once we get that out of the denominator, we have x plus y is equal to 2. Subtract the x, y is equal to 2 minus x. So this right here is a line with a slope of -1 and y-intercept of 0, 2. And if you wanted to go back on Desmos and check that, go for it. And then this one here is more similar to what we did over on the left-hand side on our first problem. So we're going to multiply both sides by r in order to get this into an r squared and to have an r on each of these. So we have r squared is equal to 10r cosine theta minus 4r sine theta. So this becomes x squared plus y squared is equal to 10x minus 4y. So let's move everything over to the left-hand side so it's a little bit easier to work with. So we have x squared minus 10x, I'm going to leave a little space, plus y squared minus 4y is equal to 0. And now we need to complete the square on both of these. So we take -10 divided by 2 is -5, square it, which gives us 25. Remember, we need to add 25 to this side as well then. And then here, our b term is -4. So we take -4 divided by 2, -2, square it, +4 plus 4 plus 4. And now we can separate this into 2 parenthetical equations. So this would be x minus 5 squared plus y minus 2 squared is equal to 29. So this is a circle with center 5, 2, and radius square root of 29. If you guys need more practice with completing the square, let me know. I'm happy to make a review video of that. Otherwise, I'm going to end this video, and then the next video will be on going the other way, converting from Cartesian to polar.